Alright, we're talking about the epsilon-delta definition of the limit, and we're trying to construct a delta. We are constrained here to the interval between 1 and 3, and we have the limit as x approaches 2 of 1 over x, and of course I'm saying it's equal to 1/2. Right? This is the direct substitution, plugging 2 directly in, and 1 over 2 is half. Okay, well, let's go down and try to look at the definition and construct a delta. I guess first let's take a look at the graph. Okay, so this line here is the graph of 1 over x, and we're approaching 2, and of course you can see here that it's equal to, and it says 0.5 or a half, and we're on the interval between 1 and 3. So here's the setup. Now remember, our delta, because we're in the interval between 1 and 3, and 2 is what we were approaching, our delta has to be greater than 0 and less than 1. Now the largest such epsilon that we can choose is epsilon would be equal to 1/2, and the largest such delta is equal to 1. Let's go back to the graph. So remember, our epsilon, the largest such epsilon, is 1/2. So here is our L, or 1/2, and then of course 1. Right? When we plug 1 into the function, we get 1 out. And so we're going to take this interval right here. This is the largest such epsilon that we can have, and that is 1/2. And of course our delta, right, large such delta is 1. That would be the difference between 2 and 3 and staying inside of this interval. Therefore, as you can see here, delta is twice epsilon. Delta is twice epsilon. But we want to go ahead and let delta equal the minimum between these two. So if our epsilon was really, really small, right, or I'd have to say less than 1/2, we would want to be choosing this to be our delta. Okay, this one here. Of course, if epsilon is 1/2, right, you just end up getting 1. But we're going to take this means the minimum number of this set right here. Now, like in the previous problems where we weren't constructed on an interval between, for example, this one 1 and 3, right, we would set it up like what I'm about to do here. Okay, so we start with the conclusion, and that is we have our f of x minus our L here, and what we want to do here is go ahead and drop the absolute value signs, taking the 1/2 over and so forth and solving for x. And I don't go through all those steps, okay, so I'm hoping you're able to get to this point right here. And therefore this says x has to be greater than 2 over 2 epsilon plus 1, right, and x has to be less than 2 over 1 minus 2 epsilon. So you want to set these up. Now remember, you flip the sign and then make this negative and then solve for x in this problem here. But we're going to let delta equal the minimum of these two right here. Minimum of either one of these. Now I choose my epsilon to be 0.1, just to give you an example here, and when we do that and simplify this down, we end up getting 1/3, and we do that here, we end up getting 1/2. Of course, which delta are we going to choose? It says the minimum, the smallest one between these two right here, and of course this is 0.5, and this is like 0.33333333, and so on. Anyway, 1/3 is less than 1/2. But you could graph both of these, let this be x, and then start taking a look at the graph, and you're going to kind of see which one we're going to always choose, even though I am listing both of these in here. Let's take a look at the graph. So we pick the one on the left, and that would be in this interval right here.